Here is my last video for probability of multiple events. So the next thing I wanted to find real quick is called sample space. That is the set of all possible outcomes for an event or activity. So a couple of quick examples, like for a coin toss, there are two elements in the sample space, heads or tails. When you roll a six-sided die, there are six elements in the sample space, 1, 2, 3, 4, 5, or 6. Oh, the tree diagram is one method that you can use to show the sample space of multiple events. So for example, in example 4, if we wanted to show the sample space for flipping two coins, we could say the first coin flip has two possible outcomes, heads or tails. Then the second outcome, if we flipped heads first, we could still get either heads or tails. If we flipped tails first, we could get heads or tails. So the bottom layer here, there are 4 total unique outcomes. So the sample space has 4 elements in it. We could have heads, heads. We could have heads, then tails. We could have tails, then heads. And we can have tails, then tails. So there are 4 unique ways this can happen. There's a 1 in 4 chance we get tails both times, a 1 in 4 chance we get heads both times. There's a 3 in 4 chance that we get heads at least once. And there is a 1/2 chance that we get one of each. A few different examples of things that we can see using a tree diagram to show this sample space. And then in my last example, you could actually use a tree diagram to illustrate the results of the roll of 2 dice. But here I used a table which does effectively the same thing for us that we needed to. So we're going to use this table to answer questions at the bottom. And you can see there are 36 elements in the sample space of rolling 2 dice because we've got 6 options for one, 6 options for the other. We get 36 unique outcomes. So my first question, what is the probability of rolling a sum of exactly 12? So let's go through and look and see if we can find when we get a sum of 12. And as we go down from the top left to the bottom right, our sum is going to get bigger. So we've got 1, 1 would give us 2. That doesn't really work. Got 3, 3, 4, 5s. So the only way that you can roll 2 dice and get a sum of 12 is 6 and 6. So that would tell us that the probability of rolling a sum of exactly 12, is 1 out of 36. That's one way that you could calculate this probability. And if we wanted to get that as a percentage, 1 out of 36 is about 2.8%. Now, what if we're looking for the probability of rolling a sum of 3 or lower? So now we're going to look at all of the ways that we can get 3 or lower. So we could look at all the ways there are to roll a sum of 1, but that's not possible because at minimum we're going to have to roll a 2. If we roll 2 1s, then that we have a sum of 2. And then we also have the possibility of rolling a 1 and a 2 or a 2 and a 1, which would give us 3. Beyond that, all of these are going to give us more than that, at least 4. So the probability of rolling a sum of 3 or lower, so there were 3 elements out of the 20 or 36 in the sample space. I can simplify this fraction because 3 goes into 36 12 times, so this is 1/12. And 1/12 is 8.3 repeating, so about 8.3% for the probability if we want to express it as a percentage. So there are two ways I can express the correct answer for this one.